I'm going to introduce you to a different way of factoring. I know the book explains factoring by grouping, and that's definitely the way most people have learned. But this is a lot of fun. Particularly, I find it's most valuable when you go on to trinomials. If you don't have some kind of visual way to organize, it feels a lot like just guessing and checking. The factor box definitely helps make it not feel that way. So. What I'm going to do, oh excuse me, that was to the third. What I'm going to do is take a 4-term polynomial, let's count them up, 1, 2, 3, 4, and I'm going to take you down to this little diagram, and down here I just have a box set up with 1, 2, 3, 4 spaces in it, and we're going to enter the 4 terms of the quadrinomial into the box, and we're going to do it like just in the same order that you would read in. So here we go this way, and then go down this way and go over here. It's like a Z for Zorro. Okay, so let's enter them in. First is what, 2x to the third, negative 14x squared, 3x, and negative 21. So let's get a little bit better look at my box. Now, one thing that's cool about the factor box is it will also tell you whether a polynomial is factorable or not. Some polynomials can be factored and some can't. They're prime. You can tell if your quadrinomial is factorable or not because the diagonals will line up. And what I mean by that is if you look at the diagonals of your factor box and you multiply them together, on this diagonal you get negative 42x to the third. And the same exact thing happens on this diagonal. Now when you are factoring a quadrinomial that can't be factored, what happens is the diagonals can never be equal, right? When you put the quadrinomial into the box in descending order, the diagonals don't end up being equal. So we can feel very confident that this is going to factor, right? I didn't find any factors here, but now I know it's not prime, that I will be able to find factors. Most people don't do the diagonal test ahead of time. Most people try to factor it, and if they feel like they can't factor it, then they test real quick to see if it's prime. So it's a really good thing to know how to do, even if you don't use it all the time. Okay, now next, let's actually find the factors. So what we want to do is just look at the first row, the 2x to the third minus 4x squared. We're just going to consider that row, and we're going to pull out the GCF. That, of course, between 2 and negative 14, the GCF would be 2. Between x to the third and x squared, we should be able to take out x squared. Okay. Now the factor box works just like a multiplication table. Whatever's up here times 2x squared has to give me 2x to the third. So then it's not hard to figure out that what has to be up here. It has to be something that I multiply by 2x squared to get 2x to the third. That, of course, is x. Okay. Same thing works over here. I've got to get something that multiplies times 2x squared to give me negative 14 x squared. Of course, that's negative 7. Okay. Lastly, down here, all I need is something that I'll multiply by x to give me 3x. That, of course, is 3. Alright? And you might not know it yet, but we've already got our factors right here. They're the outsides of the factor box. So I can go back up to my polynomial, and I can write it in factored form. is x minus 7 times 2x squared plus 3. And there is the final answer. 2 factors. Okay, all thanks to the magic factor box. Hope that helps.